April 11, 1970, a day when three brave men set out on a mission to space to explore the unknown. This date would become not just any date in space exploration history, it would become a date that overcame difficult encounters and exchanged new ideas for the future of space exploration.
The Apollo program, or the Apollo project, rose out of John F. Kennedy's desire to have America be the leader of the space race. The Soviet Union was currently the frontrunner in this race. They had launched the first man into space on April 12, 1961. That same year, on May 25th, Kennedy gave a riveting speech in which he promised to get America to the moon by the end of the decade.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
To meet Kennedy's expectations, NASA conceived the Apollo program to land astronauts on the moon and return them to Earth safely.
The first 6 Apollo missions were tests leading up to Apollo 7, the first manned Apollo flight. Apollo 11 was the first space mission to land on the moon on July 20th, 1969. There, Neil Armstrong became the first man to walk on the moon. Apollo 12 was the second Apollo mission to successfully land on the moon. Apollo 13's original intent was to explore the moon, encounter the undiscovered, and exchange their outstanding work with the world.
Apollo 13's crew consisted of Commander James A. Lovell Jr., Lunar Module Pilot Fred W. Haise Jr., and Command Module Pilot John L. Swigart Jr. Lovell was part of Gemini 7 and 12 and Apollo 8 prior to his flight with Apollo 13. Haise was a research pilot for NASA and served as a backup lunar module pilot for the Apollo 8 and Apollo 11 missions. Swigart was supposed to be the backup command module pilot, but when the original pilot came down with German measles, Swigart had to step in.
Apollo 13 was composed of 3 main areas: the lunar module, command module, and service module. The lunar module was supposed to be used for the moon's surface. The command module was where everything in the spacecraft was controlled, and the service module was where fuel, oxygen, and other supplies were stored.
Apollo 13 was supposed to land in the Frau Maro area, a large mountain range. The men were to explore the Imbrium Basin and conduct geological experiments.
Apollo 13 launched from Earth on April 11, 1970 at 2:13 p.m. from Launch Pad 39A at Kennedy Space Center in Cape Canaveral, Florida. The mission was going smooth until April 13th, 55 hours and 46 minutes into the flight. The crew did a TV broadcast to show Americans what space was like. Just 9 minutes after the broadcast, Swigart was instructed by the control center in Houston to turn on the fans in the oxygen tanks.
This loud bang occurred.
The spacecraft rocked back and forth. We didn't know what happened.
When Swigart turned the fans on, there was an unknown problem that caused the second oxygen tank to explode and leak into space. This situation was certainly not what the astronauts expected on encountering. The explosion also damaged the other oxygen tank and surrounding supplies. 200,000 miles from Earth, the crew had lost much of their electricity and water. The message of the explosion came to Houston at 9:08 p.m. on April 13th with Swigart's famous words, "Houston, we have a problem."
And this is indeed the gravest emergency probably yet in the American space program.
Next, warning signs appeared on the panel that only a third of the fuel cells were left, which were the main source of energy. The crew worked with Mission Control in Houston to fix the problem and come up with a plan to get them back to Earth with what little resources they had left. If this incident had not happened, Haise and Swigart would have become the 5th and 6th men to walk on the moon. 1 hour after the explosion, Mission Control ordered the crew to move to the lunar module, which will be used as a lifeboat. This lifeboat was built for a 45-hour lifetime, but needed to stretch to 90 hours. All non-critical systems were turned off to conserve power. The crew had to go on a water diet to preserve water. Each man can only consume 6 ounces of water a day.
To conserve electricity, the heat was turned off, and at times, temperatures reached a low of 38 degrees Fahrenheit and caused condensation. Carbon dioxide rose to extreme levels, and the crew did not have enough filters to keep the air breathable. Houston came up with a makeshift filter using the few resources on board. The lunar module lacked a sophisticated navigation system, so Lovell talked with Mission Control about the most difficult maneuver of the mission. A 5-minute engine burn that would give the lunar module enough speed to return home before its energy ran out. But the module would be out of control. Just 2 hours after rounding the moon, the crew had to use an alignment point to aim the craft, and they fired the lunar module's small engine. Once fired up, the lifeboat was out of control, but Lovell, Hayes, and Swigart successfully put the lifeboat on course to Earth.
The last part of their rescue mission was restarting the command module for re-entry into the Earth's atmosphere. Thankfully, the command module was successfully repowered, but there was one troubling question.
Had the heat shield possibly been damaged by the explosion in the surface module?
The best thing we can do now is just to listen and hope.
Thankfully, the heat shields were not damaged, and the crew entered the Earth's atmosphere just before 1 p.m. on April 17, 1970. Just after they entered the atmosphere, they lost communication with Houston. After 4 long minutes of radio silence between the crew and Mission Control, parachutes were spotted above the Pacific Ocean. The lifeboat safely splashed down into nearby Samoa, and the men and the lifeboat were taken in by the USS Iwo Jima.
Lovell, Hayes, and Swigart were awarded the Presidential Medal of Freedom by President Richard M. Nixon at the Post-Mission Services for their honorable bravery and commitment to the Apollo 13 mission. The mission of Apollo 13 was seen as a successful failure because they failed to achieve their goal, but the men were successfully brought back to Earth.
After the crew's return to Earth, an investigation was commenced to figure out why the oxygen tanks had failed. They found that the command module had undergone improvements in 1965, one of them being increasing the voltage of the heaters in the oxygen tanks from 28 to 65 volts. The thermostatic switches on the heaters were not modified to suit this change, which would cause the tanks to overheat and build up pressure if the thermostat was ever used. The tanks were damaged even more during final tests, which meant the next time they were filled with oxygen, they were potential bombs.
When Swigart was told by ground control to turn on the fan in the oxygen tanks, it started to ignite a spark inside the tank, which led to a fire, which led to such extreme pressure that the tank burst. Because the equipment inside the service module was so densely packed, a lot of equipment around the tank was damaged when it burst, including the other oxygen tank.
To get more information about the ideas exchanged by Apollo 13, we met with Professor David Raker from Cedar Crest College, who specializes in astronomy and has a large knowledge of Apollo 13.
They had to figure out some ways maybe to solve the problems down the road. One thing they did was the oxygen tank was redesigned completely. They actually added a third oxygen tank because what happened was they felt that the oxygen level dropped down very quickly, so they wanted to have a reserve just in case that happened. So that was one problem they solved. The stirring fan for the cryogenic solution, that was unsealed, so that was sealed up now. So I don't know why they didn't do that originally. The electrical power wiring in the power system bay was also put in stainless steel, so this way that because Teflon could melt, the stainless steel would not. The oxygen probes, which were more or less saying, hey, how much oxygen do I have here, were changed from aluminum to stainless steel. Again, to the temperature, they said, probably went up to about 1,000 degrees before that explosion in that one component, so it certainly would prevent that problem. And the spacecraft and also the mission control communication, the monitoring systems were upgraded, so this way if there were some problems going on earlier in the missions from then on, they would be able to detect that. So those are kind of the precautions or changes that were made.
The result of Apollo 13 was not what NASA or the world was expecting, but Apollo 13 had a huge impact on space exploration. It explored new ways to overcome obstacles in the face of death, encountered challenges that tested the most intelligent scientists in the world, and exchanged new improvement ideas for successive missions.